Yeah, good. Okay, so yeah, so I mean, the work I'm going to present to you today is very much an applied research. I think here in Australia we have, and we can talk a bit about that in the end, but we have some sort of special and specific types of research funding, and we are very much encouraged to do research with councils and see the application of it. So I'm going to talk about this work that we have been doing with the Sunshine Coast Council. Just to set a bit of the context, and I know this is not news for this group, like we are all aware of the impacts of heat waves and the risks of it and climate change. But in saying that, here in Australia, we have a very challenging, I guess, scenario ahead of us. Like extreme heat kills more in Australia than all other disasters summed up. So if we sum cyclones, flood, bushfire, landslides, actually heat waves kill more. We usually don't talk about that directly because it's really hard to pinpoint that the heat was the cause of death. It's usually attributed to, heart failure or other things. But we know that we hear a lot about the Australian fires and we hear a lot about the cyclones in the north. And we know that when we have heat waves, they tend to impact more. The councils became more aware of that because of the risks to infrastructure. There has been some cases where people rely a lot on air conditioning for those overheating moments and days, but then the infrastructure fails. And we have some spots, especially like Western Sydney, where it's far away from the beach, it's in a valley that can overheat quite significantly. And so the councils became more aware of that. Also, last week I attended the International Conference on Urban Climate, and I was reminded of this paper, which is from 2006 by Tim Oak and Winston Chow, he's the leader writer for the AR7, which is coming up for the IPCC. And he was talking about how, like specifically highlighting those points, like in 2006, Tim Oak raised a few sort of like concerns with where we were at in terms of urban climatology. And at that point, we were talking about validation of models and things like that, which has evolved a lot. Now we are able to validate future models. But there's still a big challenge with the application of that knowledge into urban design and planning, and particularly doing impact assessment after those strategies have been applied. And based on that result, actually using the policies to enforce what we know is the best practice for those things. So it was really interesting to see, because the conference was very technical in many aspects, and a lot of what we do is very technical. But when questioned about the future, his answer was, we know a lot, we are just not applying it, and we need to better understand how to bridge this. So that puts us in a good position, I think, in terms of where we are at with this specific research. The Australian context for planning framework goes from a federal to a state to local level. Largely what we do is at the local level. So in terms of implementation and protection of wind breezes, wind channels and breezes, built form impacts on climate and all that. That comes from the local government. So that's like what we call here in Queensland, our planning scheme, which is the legislation guiding that implementation. So above that, there is the regional plan, which is this one that you're seeing on the screen. And this was literally released, I'd say 3 to 4 weeks ago. It's still on a draft state. And what this means is this is not like a bylaw document, but this guides what the local governments have to do. And if you look into detail, what was really interesting for us is that we are doing a lot of this work with the council, but it came up that particularly, regional and local scale heat hazard risk assessment at the local microclimate assessment and built form investigations are needed. So the state has now recognized that we need to model and we need to design and enforce those legislations. Which is really good for us. I think in terms of, you know, the Australian Planning Institute has been pushing in the last 3 years for climate change responses, but it has always been a little bit of a high level statement. You know, we need to respond to climate change. We know it's getting warmer. How do we do it? We design for climate. We never get to the how to do that. So this is a big step on sort of that avenue for implementation. Now, this is where this project comes in. The Sunshine Coast Council came to the university with a statement of need. They know all that. They know that heat waves are costly. They know that people are at risk. They know that we are developing in a way that is not conducive to cooling, and that climate change will get that worse. They understand that they have a lot of data, but we are not necessarily making the best use of that. So the Sunshine Coast has come up with a lot of interesting documents that are very important on guiding the development. They are at the strategic level. So again, not necessarily enforced. A couple of things in June last year, so June 2022, the Sunshine Coast became a biosphere reserve, and it's the only place in the planet where there are 3 biosphere reserves like that join together. So there's the Noosa Biosphere Reserve, the Sunshine Coast Biosphere Reserve, and the Great Desert one, the Sandy Desert, which includes Bob the Island that I was talking about. So that's all part of one UNESCO Biosphere Reserve as well. The Sunshine Coast released this yellow book that you're seeing on the right. That was around 2019 to 2019, I think it came up. And that's a very nice, sort of like, it's almost a coffee table book, but very educational in terms of how to design for our climate. So the Sunshine Coast Council knows the needs of it. They are trying to push, even with like the general population, how to respond to the local climate. So based on what they wanted to achieve, what they've asked us to do was to model future scenarios for the planning scheme. So one thing I didn't say was that in the middle of it all, our planning scheme, which is our main urban legislation, is currently under review. It's revised every 10 years, and they are at the moment finalizing the 2024 version of it. So the Sunshine Coast is at a big risk. I'll just go back a bit because I didn't say that here. When we look at this area here, which is Southeast Queensland, which includes the Sunshine Coast at the north of it, it's one of the biggest migration. It has one of the largest migration rates in the world. So it's comparable to developing countries, which we know that's huge. And it's one of the biggest. So the coast is really under pressure to accommodate all those people. There is a big push to increase density in certain areas, and I'm going to show a map in a minute. And they are trying to make the planning scheme conducive to that. But they are afraid that by doing that and increasing density, we could generate more problems than we already have in terms of heat. So they asked if we could model some key specific areas that were of interest to the council. And they are around 500 by 500. So it's not necessarily a neighborhood scale, but it's more than just a side scale. What they are looking at is increasing this urban environment adaptive capacity to heat and provide efficient practices. So they really wanted us to use tools that we can communicate to the practitioners, that then you can see the results. And by seeing the results, then there's an avenue for implementation. That's not like climate's not only this very difficult science that the scientists are looking at, that there is a big important role in translating that. They are also interested in using the green infrastructure to mitigate that heat, particularly because it is part of a biosphere. It is a very green area. So the Sunshine Coast, we say it's a community of communities. We don't really have like a big, it's not a city. It's a lot of little villages. And so there's a lot of green spaces and green buffers in between these areas. And they really want to push for a climate resilient region. So as a region, the whole Sunshine Coast. So what we've proposed to them, and this is the project we are undertaking, we are on the first part. We are on the second part now, but we have finalized this first part. So there's three parts for this project. The first one was to identify the highest leverage points for the system. So to do that, we are using an STS modeling. STS stands for Social Technical Systems. So social technical systems is really a way of looking into, it comes from IT and sort of like computer engineering. It's a ways of looking into very complex system and identifying how the elements within that system support the system. So we find the ones that are most connected, and then we know that by fixing that one, it's a leverage point that will make the whole system work better. We also use, so that this is the work of a colleague of mine, Nicholas Stevens. We also modeled and mapped green infrastructure types at the landscape scale. So that was done, we attempted to use a drone to collect that data. We had a lot of constraints in terms of the restrictions of flying drones and collecting data. So we ended up collecting data with an airplane and a thermal camera at a larger scale to identify the hotspots within the region that then we knew that we could zoom in and try to model those regions into the future because they were the most critical ones. This third part, which is the modeling, was then done using NVMet for looking into those areas. Now, a little bit about the Sunshine Coast. So as I said, Brisbane is further south. It's the largest city in the region. Australia has around 25 million people, 16 million live in 5 cities. One of them is Brisbane. Sunshine Coast as a region has around 350,000, expected to increase by, in the next 10, 15 years to almost 500,000. If it keeps going in the rate that it's going. So it's very fast. The council asked us to look into that area that I said, I don't know if you can see my mouse, but like the big 2 dots, the bottom 2 dots in the larger map, you can see that that's a straight line close to the ocean. So that's the area that is the focus for development. It's a consolidated area with very big lots, like up to 1,000 square meters. The council is looking into splitting those lots and building like infill development, but also allowing to actually be built up. So that's the area that is more under pressure. We chose 3 sites, which you can see, site 1, 2, 3 on the right-hand side. They varied in form, in street orientation. The middle one, site 2, has a lot of water. You can see it's like it has a lot of inlets. They were interested to see if that would generate different outcomes in the results. So in terms of the 3 parts of the project, as I said, the first one is aimed at explaining what's there and sort of like creating, identifying these leverage points. That's the STS done by Nick Stevens, which is aimed at explaining that system. Now, it's important to note here that it's not only about climate. The STS model we've developed includes climate, but it's as green infrastructure as a whole. So it's how green infrastructure can support life within this environment. The second part was about exploring this idea of like the hotspots. So the Sunshine Coast Council is very, very rich in data. They have a lot of data. It's much richer than all the councils around here. I've worked with a few others and they don't really have much that we can use as a starting point. They haven't been collecting that type of data. Sunshine Coast is really, really rich in terms of data. So we were able to use a lot of data they had already collected to validate the data that we were collecting for those sites. So that included photogrammetry, like LiDAR, lots of different satellite images. And for the predictive modeling for the future, I know it looks a bit shocking, the top one, which is that top one is one of the 3 sites modeled to its maximum capacity. So if everyone did every single site to the maximum capacity that the council is allowing them to do, so maximum height, minimum setbacks, maximum build form. And then the second one down is the existing one. and the data that we collected, obviously we used Bureau of Meteorology data to run the scenarios and to validate that data. Now, it's important to say that this model, the top one there, which we did with the potential future scenario, that was actually done in September last year, so a year ago. It has since changed. So that big long block that you can see on the left side of that street is now a big stadium. So the Sunshine Coast is part of the Olympics in 2032. Brisbane is going to host. Sunshine Coast will have some games and some things here. So that's now a big stadium. So since we modeled, the policy for that area has already changed a bit, because we know now that the built form is not going to be as they were indicating in that first draft. Okay, so in terms of methodology, we developed 8 models. They were models for the street, the whole site and the streets themselves. We did that. What we did for each one of the sites, we did the existing and the future. So the existing was done using 3D LiDAR photogrammetry and field-based data collection for 3 species and things like that. Now, we did this using EnviMat 5. It was already version 5, but was the 5.0.3, which wasn't as well integrated with GIS yet. As of early this year, there's a much better integration. So we were really able to use the data that the council has and import into EnviMat as a basis, which means that 2 weeks of full-time modeling is now a few minutes. All that we have to do is to put that GIS into EnviMat and attribute the materials. It doesn't bring the materials, but we don't have now to actually do all the build form, which is fantastic. A lot of time saving for that. We then built the future scenarios, as I said, based on the planning scheme. We did 2 models at the neighborhood scale and 6 at the street scale. So this one, when I say 2 for the neighborhood scale and 6 at the street scale, they are really focusing on their site 3 there that you can, at the site 1 that you can see there, because that was what we call the stream A of the project. So we focused on one site. We did a lot of tests to make sure that that was going to work properly, and now we are expanding the project. So the simulations were performed for the hottest day ever recorded in the Sunshine Coast, which was the 4th of January 2014. Now, there are questions about that. Should we be modeling and running simulations with the very hottest day ever recorded, or should we be looking into future climate change scenarios, which was potentially going to be warmer, or should we be then calculating a typical day to know how those spaces perform normally? So because of the council's need, which was to know how the place is now, how it's performing in an extreme heat, we decided together with the council to run that day. But it's going to, there will be things added now in the second part, and I'm going to mention that in a minute. We run all the simulations, and the analysis we did was based on air temperature, wind speed, mean radiant temperature, and PET. There are lots of other things we could have looked at, but for the council needs, those were the most important ones. In terms of the current methodology, just to give you an idea of how labor intensive it was, on the left-hand side, that colorful map is actually the different land use that the council has attributed to those areas. So each one of the land uses has different setbacks, different heights. So we actually modeled as they were aiming to actually have those areas developed. Those 3 streets that you can see in the middle map, like the blue, the orange, and the yellow, they are actually streets that are focused for the council to create green streets. So they are sort of like really green spines, green corridors within that neighborhood. And they wanted us to model them at a more detailed street scale to see what would be the impact of that vegetation. On the right, you can see how labor intensive it was to actually define the species on EnviMat, because EnviMat has a very good library of vegetation for the European context and even North American context for some regions, but it's very poor in Australia. Not many people use ANVMAT around here. There's some people, but not many. And so our library is very poor, especially for Queensland. So what we did was we went and we identified all the trees on the site. Like the council had some data. We worked with an arborist that works for the council. We identified all the trees on the site. They were all mapped on GIS. And then what we did was the 10 most frequent trees, the ones that had more than 10 species, at least 10 species, and that were more frequent on the site. We went and we collected 10 healthy leaves to weight them to be able to put on ANVMAT that specific parameter, because that's very important for evapotranspiration, for how the software calculates that. And because they were very frequent on the site, and they are some of the main species that we can use in the Sunshine Coast, we actually went through the trouble of adding that to the ANVMAT library to a very good level of detail. This is the Sunshine Coast Council has developed, as I said, those green street typologies. They have a number of streets, a number of models that they can use. They wanted those streets to be modeled, as I said. Some of those you saw, like they were orange, yellow, and blue. They actually match with that little tile on the right-hand side on the top. And then the council gave us this sort of like this cross-section of the street of how they imagine that's going to look like. Now, they didn't give us any tree specification. So we took the main ones that we identified in the existing sites, the healthier ones, and we modeled the future scenario based on the locations that they wanted and the main vegetation sites. So here's another image that they gave us, and that was really important for us to then be able to create that model that you're seeing on the top right, and then be able to compare the before and after of how those streets would look like. Now, in terms of the results, there are some things that are not new for us. I think like they are just, almost like the council needed evidence for things that we already know, but there were some things that were very, very critical. So one thing that was quite interesting was that the prevailing wind in the Sunshine Coast is southeast, which is an ocean cool breeze. And everyone talks about that breeze. Everyone talks about preserving that breeze, and we need to preserve that breeze. However, in a very hot day like this one, the 4th of January 2014, and then we looked a lot in like big data sets of stats and run some stats to see if that was common, and that was very common to have a hot condition like what we had on the 4th of January. We need a combination of factors that includes wind that comes from northwest or north, which is the hot wind that comes from the outback or inland in Australia and the north. And so while, then we had meetings with the council where we showed these results, and their gut instinct was, but we don't want that wind. We don't want that northwest wind into the urban environment because it brings a lot of heat. And what we perceived with the simulations was that, as we know, we still need air movement. If we have like very harsh conditions with very high humidity and sun, and we don't have air movement, the PET goes through the roof. So it was really, it's really important to preserve those breezes. And we are fortunate that they sort of like work on a spine, right? Like it's southeast is the cool wind, northwest is the warm wind. They actually work together in that direction. So that's the most important direction to preserve for us. So there was big impact, as you can see on the mapping, in terms of breezes, channeling the breezes through that built up environment. However, we also had much more shade, and that improved the comfort in some areas. Like the density, even though it's an important corridor for the coast, it's very low still. So by creating those higher, sort of like more built up form, we increased shading, which reduced the PET in some areas. So we realized that with the future scenario, we didn't actually manage to decrease the vegetation more than 2 degrees. Now, I didn't mention before, but the way we modeled it, we modeled the existing site to an incredible amount of detail. Like we went with Google Street View, photogrammetry in every single facade. We identified all the materials to really run a test that was a baseline. From that one, we then validated the model with simplified models. So we started simplifying. What if we just have, brick that is light, medium, or dark, instead of all that color range. And then we run tests to see how much that would impact, to a point that we could run our validation. We could calculate R-square and RMSE to make sure that it was within an acceptable range, but the model was more simple in a way that it's easier for us to model and it's quicker to run the simulation as well. But the thing is, for the existing site, we modeled to an incredible amount of detail, but when we did the 500 by 500 for the future scenario, we kept the vegetation as it is. So that was what we told, we spoke to the council, this is your possible worst scenario, where you are increasing the built form and not improving shade and vegetation by natural sources. So this is what you were seeing here. Then to the street level ones, then we added that green street typologies. So in terms of preserving the breeze, it's I know early on when I first joined the group, like we had some conversations about wind, and I was actually running the simulations at the time. And I asked about the wind impact. It's so counterintuitive because we know this. And when we told the council we need to preserve breezes, their answer was we didn't even think about it. We were actually thinking about shade and evapotranspiration and water. We weren't actually thinking about the wind. So again, as expected, and I've seen this in many studies, air temperature remains very similar. And that's partially because it's carried around, and partially because there are so many other things impacting on the air itself. But we did notice a huge difference with mean radiant temperature and also PET, even more on the street ones that I'm going to show in a minute. And in regard to the site that you can see the image there, which has a lot of water, it wasn't looked in detail as we wished. We are going to look further into the site now for what we are calling Stream B. But yeah, we did notice that during the day there were cooler areas because they're very close to the water bodies, but they did struggle to cool down during the night, during that period that was very hot. So we just ran 24 hours because the sites were very big. We are now looking into a smaller area over 3 days of a heat wave scenario into the future. So I'm going to talk about that in a minute, but that will give us a better idea of the role of those water bodies. So in terms of the street modeling, as I said, the decreased temperature below the tree canopies returned significantly cooler. So we saw like a mean radiant temperature of around 12 degrees, almost 12 degrees cooler, which was very significant from our perspective. Then the council said, well, but that's surface temperature. Mean radiant temperature is largely surface temperature. No one is going to be lying on the ground, right? So what do we take out of it? And I said, well, we take out of it that even though the air temperature doesn't reduce that much, the mean radiant temperature reduces a lot, which means that the PET, which is how we feel about it, reduced up to 6 degrees. And now, the key thing for them was to understand that the PET, our perceived temperature, is really what puts us at risk. It's not the air temperature. It's the capacity of our bodies to cool down that will put us at risk. So by reducing that temperature to 6 degrees, they were like, okay, this is actually a significant result. In saying that, for that specific day, the mean radiant temperature was still very high, even with the trees. It was above 47 degrees, which is still in what configures like a danger for human health. So in conclusion, the results then were taken back to the council. They looked much more detail into the built form. They made some changes, which is great for us, like to see our research getting out of the desk into the real life. The mean radiant temperature was the biggest decrease, so was the biggest change that we saw. It was approximately 14 degrees in some areas, but they were small areas. That's why I said 12. 12 were actually significant areas underneath the trees of that reduction. PET reduced by 6 degrees, and the role of wind on those hot days as well was something that they weren't expecting, and I think it's very significant. Just as a side note, I've done another work with another council here in Australia, which I'm not going to mention which one it is. They have these big, mature, beautiful fig trees along a main street, which is almost the signature of that central city. They are under huge pressure to cut those fig trees because they are damaging infrastructure. And, you know, as weird as it might sound, people don't seem to like trees in public realm because of the risks and the leaves and the birds and the bats and all the things that they attract. So we suggested to make some modeling to show the value of those trees, right? We were doing another project and they asked, are you able to model that street? And we did. And unfortunately, we found that those specific fig trees, as they were in the places that they were actually working in heat waves as a heat source because they were blocking the wind. So even though during the day they were nice underneath the trees, like the average wasn't, you know, if you consider like 3 days of a heat wave with increased temperatures and heat trapped into that landscape, over 3 years of that deficiency of cooling, it was actually significantly compromising. So it wasn't the result we wanted to give to the council. We are looking at all the reasons why that could have happened, if it could be caused by the built form as well, or if there were other ways that we should be planting the trees so they don't actually get to that outcome. So yeah, and as a side note, like final note, the models have limitations, but they are powerful. Like they obviously are just models. We know they're not 100% realistic, even though we put a lot of detail in it. But they have been validated and they are all comparative before and after. So they were really powerful in that sense. Another thing I wanted to say was that it was really good, I think, and rewarding for us. And this is like a happy story to almost finish up with. The council took the results of this study and applied for a disaster ready fund, which is the national fund from the Australian federal government. And they got 3.2 million from the federal government to plant trees. So now they came back to us and said, this is a significant result. We now know the role of trees. We have the trees. How do we plant them to avoid blocking the wind? So now we have another project that we are looking into different configurations of planting to see how that could be optimized in this context. And just to finalize, so now we are looking into, that was all stream A of this project. Now we are looking into stream B. We have 6 new sites, including one that they call the Olympic Legacy site, which includes the area where the athletes are going to be, where the accommodation is going to be, which is intended at giving back to the community later on. So it's going to be a higher density site as well, and they are interested on that. We are going to have one sample site where we are going to do a lot of tests on that. And that's based on the IPCC projections, the RCP 8.5, which is the high emission scenario, basically, if we don't do anything, business as usual. And then we looked into what the data looked into the future, and we were willing to do 2050 because it's more relevant for planning, right? Like for legislation, we can't actually look 100 years in the future because the councils need to respond now. So we looked into 2050, and the issue was that it actually didn't show that much heating for our context. It wasn't that significant, and based on the tests we did, it didn't actually show much of an impact. So we looked into 2070, and because we are looking at heat waves and heat wave sort of like a recurrent heat waves. The 2070 had more heat waves, so they had more consecutive days of hot weather that then we could model. So we are in conversations with the council now to understand what is it that they want. If they want the extreme scenario that is probably likely to happen anyway, but it's a projection for 2070, or if we model 2050. We are also looking back into the STS model, into those leverage points to see how we can model them to then see, okay, so if we do this little change, there's a big impact in the system. And comparing all that with, green infrastructure that exists, that is looking into embellishing new developments rather than actually responding to climate, to see how we could do better. And the last thing is testing those optimal configurations for the grant that now the council got as well. So this is the project we have ongoing. It's a 2-year project. It still has until mid next year to finalize. And that's me. I'm not by myself. I have a team, and they are very capable and very good. So Majid and Soha, they are both research assistants who worked with us in this first part. Thank you. Thank you for listening. I know it's a lot, but yeah, it's a long and I don't know, I find it really interesting project. So yeah, I would be happy to discuss.